In this video, we're going to be looking at cracking of hydrocarbons, that is also known as cracking. So when crude oil is mined out of the ground, when it's taken out of the ground, we don't just use it in its raw form. It needs to undergo what we call fractional distillation, which is where you put it in a chamber that you heat up. And since crude oil is made up of hydrocarbon chains of various lengths, some chains which are heavy will only rise to a low level in your chamber, whereas the lighter chains will rise a lot higher. And through this, we're able to separate crude oil into different chain lengths of molecules that are useful for different purposes. So your shorter chains are, for example, used as petrol. A little bit longer and we're at kerosene or jet fuel. A bit longer and we're at diesel. Okay, so that's what your fractional distillation is for. But what scientists have found is that even after fractional distillation, we can take these longer chains and we can put them through a process called cracking in order to break these longer chains into shorter chains so that we have more of these shorter chained molecules to use as petrol, jet fuel, diesel, etc. That is what cracking is. It's where you take these long molecules and you break them up into shorter, more useful molecules. So your textbook says cracking is the process by which longer chain hydrocarbon molecules are broken down into shorter, very important, more useful molecules. So this description in your book is a bit of a mess. So I'm just going to discuss with you what is important. You get two different types of cracking. There's thermal cracking and there's catalytic cracking. Thermal cracking, you need to know, takes place at high pressures and high temperatures. You do not need to know the specifics of those high temperatures and pressures. And without a catalyst. There will not be a catalyst present when we have thermal cracking taking place. On the other hand, catalytic cracking, you will find happens at relatively low, so compared to thermal cracking, lower temperatures and pressures. There will still be heat, we will still supply heat. So if we look at an arrow in a reaction of thermal cracking, you're going to see we will write down high temperature and pressure, right? But when we are looking at catalytic cracking, we're going to have some catalyst and we are going to have some amount of heat provided as well. You're going to be able to know the difference between thermal, whether it's thermal or catalytic cracking, based on the reaction conditions. Your textbook is not very specific about which one forms what, so just know whenever we have cracking, we can have two products forming. We always start off with a reactant, right? Our reactant is going to be an alkane, some type of alkane. The products of both, so either thermal or catalytic cracking, will be an alkane plus an alkene, or you might find an alkene plus hydrogen gas. So you can get either set of products. Okay, neither is specific to thermal or catalytic cracking from what I understand after all of the textbooks that I've read. But nowhere on the internet, nowhere in textbooks are they very specific about which type of cracking forms which product. So we are just going to go with cracking can result in the formation of alkanes and alkenes or alkenes and hydrogen gas. Okay? Thermal cracking, high temperature, high pressure. Catalytic cracking, presence of a catalyst and heat. My research has also led me to find out that the catalyst normally present in catalytic cracking is zeolite. Your textbook says platinum, palladium or nickel, but you don't need to know the specifics, so it's okay. Either one, you can memorize, don't memorize, it's up to you. All that I said is important is all that is important. So let's look at a few examples. Here we have ethane in the presence of heat and a catalyst, forming ethene and hydrogen. Since we are forming an alkene and hydrogen gas, we know that this over here is going to be cracking. We can identify what type of cracking by looking at the reaction conditions. We have heat and a catalyst, so we know that this is catalytic cracking. And that's as much as you need to know. I will not tell you ethane undergoes cracking, tell me the products. I might ask you for the general products, but I won't ask you for specific products because it's very difficult to tell how much your substance will crack or break up by. Okay, so let's look at the next example. We have butane. Butane, it's a hydrocarbon, a saturated hydrocarbon. We put it under conditions of high temperature, high pressure, and we form methane and prop-1ene. Methane is an alkane. Prop-1ene is an alkene. So we have here an alkane and alkene forming. So we know that this is a cracking reaction. We are breaking up our butane into shorter chains. We know that this is specifically thermal cracking because it happens at high temperatures and high pressures. So this is thermal cracking. Again, you don't need to be able to tell me what results as a result of this reaction. Just be able to identify that it is cracking, specifically thermal cracking. So if we scroll a bit down, I have a few more examples. Here we also have butane, and here is butane, unfortunately spelled incorrectly, but it's butane undergoing cracking as well. If we compare the first reaction I showed you, can you see the products are different? Here we had an alkane and alkene forming, but here we have but-1-ene, which is an alkene, and hydrogen gas forming. So there's no way, grade 12, that I will ask you what products form, unless I ask you for the general products, which would be an alkane and an alkene, or an alkene and hydrogen gas. But I'll never ask you for specific products. I will just ask you to tell me what type of cracking takes place. So we know that this is cracking because we have an alkene and hydrogen gas forming. Specifically, since we have high temperature and pressure, this is thermal cracking. If we go a bit down, can you see the product here is different from the product here because we've cracked it even further. We took this and we cracked it even more. Okay, so now we have as our product ethene, ethene, and hydrogen. We took this compound and we split it in half, and we also had hydrogen gas as a product. Okay, you don't need to be able to tell me again the specific product that form, but be able to tell me this is cracking because it's broken up into smaller chains and hydrogen gas, and specifically it's thermal cracking because it is taking place at high temperatures and high pressures. So this brings us to the end of this video and the end of elimination reactions. You'll be able now to complete the exercise on elimination reactions.